Thanks everybody for joining us. This looks a little bit different. I'm not Akanksha, as you may have noticed. And thanks for all your feedback on the survey. And so we decided to make this meeting a little bit bigger, a little bit broader topic. We included it into the SIG community of Operate First, that we can reach more people and also create more content for all of you. So thanks for this. In case you want to still participate in this link, it's in the email that you maybe got. If not, I put this in the chat here too. So we are always open for new feedback, new topics. As you see on the meetup page, you can always bring your topics or even requests for a topic in there, and we will try to create some new content for the future and for future meetings. So bringing it to the SIG Operate First community also means including Carsten Wade from the OSPO, who is mostly joining us here. And we're also meeting on a bi-weekly basis on Thursdays. If you're interested, feel free to join. But this year is the more technical demonstration presentation part, so it's fine if you just stay here. And luckily, and as always, we will record, which I already started. If you have questions, put them in the chat. And most of the Q&As will be done after Sally's great presentation. And she already wrote a pretty great blog on Operate First. I put it also in the link here.
I have it in my slides also.
Oh, even better.
And I'll export the slides and send them to you so you can share them.
Thank you. So
yeah,
not only the recordings will be on YouTube, I will send out the link then during the week when we got all this. I will also put Sally's presentation as a PDF publicly to everybody in our repo. And so thanks for Sally hunting data. She's a senior software engineer at Red Hat since 2015, right?
Yeah.
Okay, perfect. And she's with me at the Emerging Technologies department in the office of the CTO. And the stage is yours, Sally. Thank you.
I'll share my slides first to make sure I have that taken care of. Let me know if you see them.
Yes, at least I can see them.
Cool. Does that look better?
It's fine for me, yes.
Yeah, okay. It's
like
they're
visible. They're
full
visible,
screen. Yeah, I can't see you now, so you can see me?
Yes.
Okay.
We can see you in the camera perfectly, and the presentation is also good.
All right, perfect. If anything's going wrong, just let me know. So this talk, it's about OpenTelemetry. We'll talk a little bit about OpenTelemetry, but specifically how it's running and Operate First. So I've been looking at OpenTelemetry over the past year or so. It started because in upstream, so in Cryo, it's the runtime for OpenShift, the container runtime. They wanted to add some instrumentation to generate trace data. So I looked into OpenTelemetry and added some instrumentation for that. That's experimental. And then upstream in Kubernetes, the same thing was happening with the Kube API server. A bit of instrumentation went in, and it's also experimental, but the Kube API server will generate trace data. And then also in the kubelet, and now in etcd, and I think the DNS operator in OpenShift. So that's why I started looking at it. And that is tracing in the core of like OpenShift and Kubernetes. That's not what we're talking about today. We're talking more about how like a regular user not in the core of Kubernetes can add tracing to their applications, or an application owner or developer. So OpenTelemetry is a sort of new project. It was a combination of the merging of two communities, Open Census and Open Tracing, and that was just back in 2019. Both of those communities realized there was a huge overlap, and that it would be better if they became one community. And so that's where OpenTelemetry came from. And OpenTelemetry is a set of APIs, SDKs, instrumentation libraries for for telemetry data, and it offers a standard protocol, a standard data structure format for traces, metrics, and logs. Yeah. So why is this important? Well, OpenTelemetry enables an application owner to instrument their application once, and that data can then be exported to a variety of backends and a variety of vendors. So you could be collecting traces, metrics, logs, and with a single OpenTelemetry collector, then you can pass that off to Jaeger, to Splunk, to any vendor. You're not locked into a particular vendor or backend. You can, that choice is left to you. Whereas before, say you wanted to export data to Jaeger from an application, you'd have to go and get the Jaeger API and, you know, instrument it specifically to generate Jaeger like traces. And you can quickly see where that would be going. It would, every time you want to add a new backend, you'd have to add new instrumentation. So now instrument once, send it wherever. That's good for application owners, and it's also good for the tools owners or developers or vendors, because they can now focus on the more interesting part of telemetry, which is like the visualization and the analysis of, and the community then has this central way of defining what is that data. So yeah, I think I probably included information of the next few slides already, but telemetry is usually talking about traces, metrics, and logs. In OpenTelemetry, the tracing and metrics APIs are stable. They've been around for a good year. The logs are still experimental. So that's why we started looking at traces first. And also metrics, most people have a solution for metrics that works, like Prometheus. And yes. Yep, so I already said this. OpenTelemetry is it's a way, they standardized, they created a protocol for telemetry data, and that made it so that vendor neutral, interoperable. So what is a trace? Because that's what we're focused on. It just, a trace is a measure of end-to-end latency for a request. So consider like a shopping retail app. It's like the time it takes for you to put something in the cart and then the payment. Like there's, I linked a very good example from KubeCon, a talk, and this is a link that I'll share with you later. But this talk, the whole talk was about correlating telemetry data, and I didn't mention it before, but that's the other really important benefit of this project, OpenTelemetry, because when you can correlate logs, traces, metrics, you can debug an issue like with much easier, much faster. And the example from this talk that I encourage you all to watch was a checkout service, and they talked about latency, like up to 5 seconds between the checkout and the payment service, and it was not obvious what was going on until you could get the full view of correlating metrics and traces. And what it turned out to be was in the payment service, it kept retrying and eventually succeeding. So the errors never like made it up to the logs. So it wasn't obvious that something was failing. It just looked like it was just taking a really long time. But quickly, if you looked at an individual trace, you could see that a lot of these short requests were being retried, 5 to 10 times. And it was because like 3 out of the 5 nodes had an incorrect API token. And so it would keep retrying, and like 2 of the 5 were good. So eventually it would pass, but that was creating a very long latency. And it was, it would have taken a lot longer to figure out if you didn't have that correlation between the traces and the metrics. And also you're able to rule out things like, was it a problem with the host? Like, was one of the nodes, was the cloud going down? And, all of that information makes debugging easier. And in modern applications and distributed applications, and applications are just made microservices, made up of dozens of services, sometimes traveling across nodes. And with metrics and logs, you don't get the cross-service boundary that you do with traces. So, and all of them are strung together with the metadata that OpenTelemetry provides, like key value pairs. You connect to everything basically with OpenTelemetry. And a span is the building block of a trace. So here I have the API server and etcd. They individual spans, but if there were a problem, you could dig in and look at which. You can see like the API server is taking way longer than Etsy. I should preface, I should have said this in the beginning, that I am not an expert in like data analysis whatsoever. I just am showing you this. I'm sharing this talk with you to show you how you can set up tracing in your applications. Yes. So again, instrumenting, you import the OpenTelemetry libraries, add a few lines of code to create spans and to export spans. And then that's the application side. The OpenTelemetry collector you run outside of your application, and that collects all of the data. It can collect all things, traces, metrics, logs, and then funnels them out to, depending on how you configure the collector, you can configure multiple exporters to send the data to lots of places. And then from the collector, there's the backends, and that's where you get your visualization, like Jaeger, queries, consoles. And here's just a visualization of that. A typical pipeline in the OpenTelemetry collector is you have several receivers. Then you process the data. So OpenTelemetry also provides libraries for processing. So you can export only the data that's important to you. So it's not that is, it can be very expensive to move all of this data around. So you can really pinpoint which things you want to send to your backends. And here's what a typical receiver looks like in an OpenTelemetry collector. A lot of things can be used as defaults. Like I'll show you this later running in Operate First. But then, so there's receivers, there are processors, and then exporters. And in the application that I'll show you, we have a Jaeger and a logging exporter. And so sometimes you want to have multiple OpenTelemetry collectors. Say you have 6 nodes and you want to collect some data from the host from each of those nodes. You could have a OpenTelemetry collector running on each node and then collecting information from your application from the host. And then you might have a central collector a single central collector, which they're actually the same thing. They're just, this one is configured to accept OTLP data and export OTLP to export to the OpenTelemetry collector, and the agents are, and then the collector can be configured to receive OTLP data and then export to the backends. And so you can aggregate from all of your nodes into a single collector, and that's why oftentimes you'll see the agent, but don't be confused because it's really just a second collector, the same thing. So all of this sounds pretty complicated, and it is, except for in the smog cluster, we have some operators running. I'll start to open my tab. So here is the smog cluster. Everyone can see still, yeah? And these are all of the operators currently installed in smog. I just want to make sure everyone can still hear me, yeah?
Yes, all is great. Thank you, Sarah.
Thank you. The two that are specific to OpenTelemetry are the redhat OpenShift distributed tracing platform and the distributed tracing data collection. This is otherwise known as Jaeger operator. It basically is the Jaeger operator with some opinions. So for instance, it's configured to watch all namespaces. It has some RBAC, some permissions, but it is a deployment of the Jaeger operator. And same here, this is a deployment of the OpenTelemetry collector operator. So let me show you how convenient these are when you want to collect data from your applications. Say you have an OpenShift cluster such as this, and you go to the operator hub and you choose these two operators and you click install, and those are installed. You don't have to worry about that. And then you have your application. I think I'll show that next. I put these in order probably for a reason, so I'll just go down the line. Here is an application I have running in the smog cluster. It is in, it's a simple web server. And I can show you that I have let me back up. The Jaeger operator and the OpenTelemetry collector operator. Let me explain what they are. So both operators are watching all namespaces in the cluster. And I'm going to start with Jaeger because it's simpler. If you create an instance of its custom resource, so operators are configured to manage custom resources. The Jaeger operator custom resource is a Jaeger. I'll show that to you. And it's really not anything. It's like the existence of this custom resource is what the important thing is. So the operator watches if there's an instance of Jaeger in a namespace, a bunch of things are triggered. So as soon as the operator notices there's a Jaeger, you get services, deployments, config maps, secrets, and a route for your Jaeger front end. And I'll show that in a minute. And similarly, the OpenTelemetry collector operator is watching all namespaces. And if you create a simple instance of an OpenTelemetry collector, it's called, that you also have to give the config for. And but if that exists in a namespace, same thing happens. You get services, routes, config maps, deployments are just triggered to be created. And then if you delete these two custom resources, everything goes away. So in my project, I have my simple Go application running. It's a simple web server. And then I have a Jaeger and an OpenTelemetry collector. I have to speed up so I can show you these things because we're running out of time. First, I will show you the instrumentation. It's right here. And I'm going to breeze through it because all of these things are there's such a very active community. If you want to instrument your application for OpenTelemetry, you go to the documentation, and it's nothing you really have to figure out. You just have to put a few lines of code in the right place. So for instance, with this logging configuration, I now have logs where every single log has the span ID and the trace ID. So with that, you can correlate logs with traces very easy. Down here, these are the three things. You have a trace exporter and a processor, and then a tracer provider that creates spans. And the rest of this is just a simple Go hello world web application. All right. That Jaeger and the OpenTelemetry collector I want to show you. It's so simple. This is it. Like, this will create a thing called a Jaeger. And when that thing is in your namespace, all of those deployments, services, routes are triggered because the Jaeger operator is running in the cluster. Same thing with this is called an OpenTelemetry collector. I also have this config map is to enable HTTPS. You get a CA, and you can volume mount that to get TLS certs. So, but here's the custom resource that is managed by the collector operator. And remember, in the slides, I showed you the receiver a lot, and I told you a lot of things are just default. There are default ports and default locations. So if you're just using defaults, that's all you need to configure. A processor, I'm not doing anything special, so it's nothing. And then the exporter, remember I told you I have logging and Jaeger. So the Jaeger is specific to the namespace service. So that's the only variable here. So you'd have to template, make a template for this for your namespace or something. And then a pipeline is just, you've got your receivers, your processors, and your exporters. All right, so let's see it all in action very quickly. We'll go back to, we'll go here. And to the routes. So here's my sample application. I told you it was super simple. I'm just going to create some network activity. I have a way more interesting applications that I found from the Quarkus people at OpenShift. It's amazing. And I linked it in the slide, so I'll show that to you before we go. But here are the routes. So I didn't really have to do anything to get this working. I had a few lines of code in my simple Go app. I knew that the Jaeger and the OpenTelemetry operators were running in the cluster, so I just created those two simple objects in my namespace, and that is all. And you can see that, I'm looking for a trace that has like some logs attached to it, but so if I was, looking at this application and it was something real, I might notice that this took a lot extra time, and I might dig in and find out, there would be logs here telling me why. So we need to stop for questions, I suppose, but before I do, this is the more interesting application. Definitely check it out. It's 2 lines. It's right here. If you have a cluster running and you launch these 2, you get all of this stuff running and lots of traces. And so I would recommend that. And then I'm actually going to switch my application to that. And then here's the blog that probably explains everything I just said in much more clear fashion. This tells everything that I did, and you can look at like the OpenTelemetry collector instance and all. I am going to stop presenting.
Thank you, Sally. That was amazing.
And
On
I'd like
point.
to, I'm hoping there are some questions, anything I can help with.
Yeah.
I really had
Tassilio, I'm saying it right. Go ahead. You can start.
Hello. Thanks, Sally, for your presentation first. There's something that I miss in your code. Are you logging to the default output, like system.out.println, or you have to output to another, or you have to log in another output?
I'm having trouble hearing you. I'm sorry, but so in my code, I with OpenTelemetry, you only need to instrument a an exporter, and that is specific to the language, and a tracer provider to generate the traces, and then the processor. I think there is a place in the code, once you have all of three of those things, you can create a span, and maybe that's there in the Go code if you look for it. So I didn't point that out. Maybe that's what you're missing. Let's see.
Okay for you, Tassilio?
Yes, I think.
Okay.
It's online. If you have that up, would be line. Yeah, I didn't point that out. It would be like line 158, where you define like what the tracer is. You create like a named. It can be any name, and then you can see I generated the span, and then you always defer the span to end at the end of the. Yeah.
Before I go to the next questions, we are over time. Everybody wants to leave. That's fine. Sally, are you still okay for a few more minutes?
Yeah. Oh, yeah. I am.
Okay. Then you go ahead. Before we go to the typed one, Raksha, please go ahead.
Yeah. So thanks, Sally. That was really interesting. So I'm working on OpenTelemetry collector myself and trying to do the traces integrated with Honeycomb. But what I did run into was deploying OpenTelemetry collector. So first question is, in order to get I think you have that hotel called YAML. So in order to be able to use that, is that like the operator needs to be enabled on your respective cluster? Because I don't think right. Okay.
Well, yeah, it makes it easier. So, but you don't. Before the OpenTelemetry collector was finished, because it was finished pretty recently, I would just deploy the OpenTelemetry collector itself in my within the namespace with my application, or in another with an endpoint that my application could reach. So you don't need the operator running, but I wanted to show how convenient it is if you have the operator running, because it does everything for you. All you need is that simple pipeline of here are my receivers, my exporters, and then all of the services that everything's created for you by the operator and managed.
Okay. I do have a follow-up question. Can I go ahead just because we are running? Okay. So I wanted to know which port you expose, because I had like a lot of trouble exposing the gRPC port, which is by default. And I had to make explicit additions to ensure the HTTP protocol was enabled. And I still have a lot of issues running into it, but just wanted to understand if you faced anything like that.
Yes.
And just had to, okay.
It is a lot of trial and error. And with the operator, though, again, it makes it easy. But let's just look. Let me look real quick at the code here. So it's this. It is. So this, causes me much stress.
Right.
So the OpenTelemetry service address, right? This is the default port.
Yeah.
So that seems to always work. And then this is like the Kubernetes service name, but you can you can probably, you know, find that for yourself. But yeah, this dial context and then once that connection is there, that's what you use to create the trace exporter. So this connection has to be set up right. And that's probably,
Okay.
yeah. And then once you have the exporter, it's sort of like, you use that to create the tracer provider or the processor. And then you use the processor to create the tracer provider. Yeah.
Gotcha. Okay.
Yep.
Thank you. Thank you so much.
And then once all those are working, that's when it's super easy because you can just do something like this, you know, and wherever you want.
Mhm.
Yep.
Awesome.
Okay, then we had a few questions during the presentation. The example link to the KubeCon as posted here, I will publish Sally's presentation during this week on our GitHub repository. The link is in here, also on our website.
And I will get the link now for those of you that can't wait. I'll just get the link to the talk. It's one of my favorite. I'll just put it in the chat, but it is in my slides.
Yeah.
I'll put it. So yeah, I've watched this 3, 4, 5 times. Nice. Whenever I like want to really remind myself about how things work, that's what I watch.
Thank you so much.
Yeah.
Second was a question, can we also access to instrumented Kubernetes version from MERT? What do you mean by this?
So at the presentation, you mentioned that you're also instrumenting Kube APIs. So the traces are being generated from there.
Yeah.
For example, when I have access to Smart Cluster, will I be able to get those traces from the underlying platform?
Yes. So the APIs are language specific. So there's different OpenTelemetry libraries that's the stuff that you have to put in your application, right?
Mm-hmm.
Yeah. There is one language, I believe it's Java, that there's the OpenTelemetry collector operator has another resource called an auto instrumentation or something.
Yeah.
Yeah. And so it will inject all the instrumentation into your application for you. And that's really nice. That's the goal probably of all the languages. And that's where we're going. But right now you have to instrument your application with other languages. But if you use that operator, the OpenTelemetry collector operator, you can create an instance of that in your namespace. And I've never tried it because I don't know anything about Java, but I suppose it must work. Yeah.
Yeah, I tried auto instrumentation. It works very well. Not in the OpenShift cluster, but using another application. But I understood that you also trace the Kubernetes itself. Did I misunderstand that?
Oh, I mentioned that in the beginning because that's where I started with OpenTelemetry. It's all experimental, and like so you'd have to turn the feature gates on for Kubelet, Kube API server, etcd, and Cryo. They all have instrumentation, but they're all turned off by default. And so that would get really interesting because you could watch, you could correlate things that are happening at that level with your application.
Yes.
And then with the host. So yeah, but I haven't had the time to be able to set up a really good application for that. And I'm hoping that someone else does and shows it off.
Okay. Sounds great. Thank you for the presentation.
Yeah.
Okay, and then Sally mentioned the Smoke cluster, which is on Operate First. And when you want to start there, this is the link, and you see the button to the Smoke cluster. And this would be the one that she was talking about. And if you want to get an idea how to start there, then it's also on our webpage, operatefirst.cloud, or this community handbook. And the onboarding process, we try to explain it really well, but I am really thankful for feedback from especially new beginners, because at some point you lose what you have to explain to make it easy for everyone to onboard. So just contact me what you are missing. And as I said, we are on updating the website constantly. And right now we're focusing on the entry points for easy beginning. So any more questions? And thanks for your time so far.
Yeah, and once you do have access to the Operate First cloud, which I believe is pretty easy to get, you have to sign up. Then that application I was showing you is public. You can look at all of the routes. They're in the blog too. So.
Okay. Sally, thank you for your time. Thank you for more time than you signed up for. Thank you
Thanks for
everybody else for
having me.
staying. No, I'm totally welcome. If you need more
It made me
details.
go back. It made me go back and remember everything. Over the past few days, I had to refresh my memory. So
That's
good for me.
okay. So thank you all, and hopefully see you again in 2 weeks. I will let you know what's coming up then. It's maybe App Curio that we're talking about with some guys, which can be maybe presented. Otherwise, look up the old YouTube videos from our other meetings. Sign up for Operate First channel, and thanks for joining us. Have a wonderful rest of the day. Thank you. Bye-bye.